Today we're talking about section 6.4, which is polynomial functions. In this section, we're going to start to discuss some of the details of polynomials. We're going to discuss their graphs specifically. We're also going to start discussing some of the characteristics, whether they're even, whether they're odd, some of those things, and how we recognize those and what that tells us from the graph. So let's go ahead and start taking some definitions down. The first one is, what is the degree of a polynomial? And the degree, the polynomial is just an expression that has exponents on the variables. So this is a really long, complex, general format. We don't use that very often. It's in the definition, but we won't typically go back to that very often. The leading coefficient is the important part, and that's the coefficient of the term with the highest degree. So what you're looking for there is whatever the biggest exponent on the value of x is, it's the number in front of the x. And so we'll go look at an example of how to pull some of those things out. And then the degree is the highest exponent value on the x. So looking at these values here in this table, a constant function has no variables. So the expression is just 9. That's what we're looking at, the number 9. It's of degree 0 because there are no variables. There's no x values there. The leading coefficient then would just be 9, because technically you could have 9x to the 0 power, and it's 9. So if it's a constant, it is the leading coefficient. A linear is one of degree 1. So that's x to the first, or just x. The degree of that is 1, and the leading coefficient is the number in front of x, which is also 1, because there's nothing there. Now, they're not always going to be the same like that. For instance, the quadratic. We have 3x squared plus 4x minus 5. 3x squared is the highest exponent value on the x. We have a 2. So that's the degree. The leading coefficient then is the number in front of the x, which is a 3. And then a cubic is anything to the third power, so 4x cubed minus 6. The cube is the degree, that's 3, and the leading coefficient then is 4. So they give us some examples of functions. First, they want us to state the degree and leading coefficient of each polynomial in one variable, but if it's not, we have to explain why it's not. So taking a look at these, we have 7x to the fourth plus 5x squared plus x minus 9. What we want to know is, is this a polynomial in one variable? Well, there's only one variable, so it's a polynomial in one variable. So what is the degree of it? Well, the degree is going to be 4, because we're looking at this term here. It has the biggest exponent value of any of our terms. So what's the leading coefficient of that? The leading coefficient then would be the number out front, which is just 7. Now this one, the key here, in one variable. What do we have in this one? There's a second variable here. We have y's. So this is not a polynomial in one variable, and asks us to explain why. Because two variables are present. Okay, so they want us to now evaluate these functions at the given values. We've done this before with other things, but now we're making them new polynomials essentially, because we're given values that aren't numbers. So we've done this before where I say, okay, find me q of 2 or something like that. We're not doing that this time. We're actually doing it of q of a plus 1 minus 2q of a. So we're really going in and substituting in some other variables here. So q of a plus 1. What this means is, inside of q, everywhere there's an x, we're going to replace it with a plus 1. So I have a plus 1, the quantity squared, plus 3 times a plus 1 plus 4. So that's all this first piece, q of a plus 1. Everywhere that I saw an x, I replaced it with a plus 1. Now minus 2 times q of a. So now everywhere there's an x, I'm just going to replace it with an a. A squared plus 3a plus 4. And it's negative 2 times that whole thing. So here we're going to multiply this out so we can simplify. So we FOIL this, so we end up with a squared plus 2a plus 1 plus 3a plus 3, distribute that, plus 4, and now I distribute the negative 2. Minus 2a squared minus 6a minus 8. Just distribute that minus 2 the whole way across. And now we combine like terms. A squared minus 2a squared is minus a squared. 2a plus 3a is 5a. Minus 6a is going to be minus a. So you can cross them off as you use them, so it kind of helps you keep track. And then we have 1 plus 3 is 4. Plus 4 is 8. Minus 8 is just 0. And so we have negative a squared minus a is our final answer there. And now this one's a little simpler, just taking f of b squared. So everywhere there's an x, we're going to replace it with b squared. So f of b squared is equal to 2 times b squared squared plus 3 times b squared minus 1. So b squared squared is b to the 4th. So I'd have 2b to the 4th plus 3b squared minus 1. And there are no like terms, so then that would be our final answer. So we're doing the same thing we did with this a chapter ago, or 2 chapters ago, when we just simply substituted in. But this time it's other polynomials that we're substituting in, and so you have to evaluate those things and simplify as much as possible. I now want to give you guys some examples of graphs of these various types. These are the most common types of polynomials that we'll see the most often. So I want you guys to put these sketches in your notes. So the constant, if I have a graph, it's just going to be a straight line. So it's up here. It's just some straight line function. It could also go up and down this way. Linear is going to be a diagonal line of some kind. So if I have my graph, I have this as my function. Quadratic, we know, we just spent a whole chapter on this. It's going to be a parabola in shape. Now this is where we're starting to get into ones where we haven't done them so much. So constant, linear, and quadratic we should know. Cubic looks something like this, or some variety of that. So really, as you add, so this is degree equals 0, degree equals 1, degree equals 2, degree equals 3. Now we're getting into degree equals 4. As you add degree values, so as you increase in degree, all you're doing really is adding curves. So a quartic, I'm adding another curve, so it looks kind of like a W. And then a quintic, I add another curve. So we do something like that. So you just almost keep adding in these curves or the humps as you go. And so those are just very, very general examples of what those graphs can look like. And again, it could be any sort of variation of those things. Alright, so more definition, or another definition here is the end behavior, and what that is what it's doing as it approaches positive infinity and as it approaches negative infinity. So you want to look on each end and say, is it going up, is it going down, is it going to positive infinity, is it going to negative infinity? And so I'll show you some examples of, essentially this is the degree. So we're looking here at what is the degree. Is the degree even and positive? Is the degree even and negative? Is the degree odd and positive? And is the degree odd and negative? it's even and positive, that could be x to the second, x to the fourth, x to the sixth, whatever. And the leading coefficient. So this is the degree, and this is the leading coefficient. Okay, so that's kind of what I'm talking about here. It's going to be like the quartic or quintic. It's going to both go in the same, both go up. But if it's negative, then they both go down. So the end behavior would be negative infinity. So evens always do the same thing. So when you have squares, quartics, to the sixth, to the eighth, whatever, they're always going to do the same thing. Odds go opposite directions. So if it's positive, it's going to move up, and it's going to keep going up. So it goes down to negative infinity and up to positive infinity, or the opposite of that. If it's negative, it would come down and then keep going down. So those are, again, very general versions of that. And we're not going to graph those yet. We will before the end of the chapter. But for right now, in the next example that we're going to look at, we're essentially just going to look at a couple of graphs and determine what is the end behavior, and is it going to be an even, is it going to be an odd, what are we looking at for these particular functions. So you just want to have a general idea of that, and then I think once we look at an example of it, it'll help clear things up a little bit. Okay, so if I give you a graph that looks something like this. They want us to do three things. Describe the end behavior. So what we do is say, as x approaches negative infinity, f of x, the function, approaches what? And as x approaches positive infinity, f of x approaches what? So as x approaches negative infinity, you're going out this direction. What are we doing? This graph is going down to negative infinity. So as x approaches negative infinity, the function approaches negative infinity. And as x approaches infinity, out this way, what's the function doing? It's also approaching negative infinity. So the end behavior for both of those is approaching negative infinity. Then we want to ask ourselves whether it represents an odd or an even degree polynomial. Well, are they both going the same way, or are they going opposite ways? They're both going the same, so this is going to be an even polynomial, because both ends go the same direction. And the number of real zeros, remember, where do real zeros occur? That's nothing new. They occur wherever it crosses the x-axis. So how many are there? We have 2 real zeros. So the end behavior, even or odd, and how many real zeros. So let's look at a different function here. So when I draw this, so as x approaches negative infinity, f of x approaches what? As x approaches positive infinity, f of x approaches what? So as x approaches negative infinity, as you're going out this direction, what is the function doing? It's approaching negative infinity. As f of x as x approaches positive infinity, what's x doing? Or f of x doing? It's approaching positive infinity. Are they going the same way? No, they're going 2 different directions. So it's what kind? It's an odd function. How many real zeros do we have? We just have 1. How many imaginaries would we have? We'd have 4. So it is an odd with 1 real zero. That's all you're doing on that. You're looking at, so as you're going out to negative, the negative side, is it going up or down? As you go to the positive side, is it going up or down? Is it even or odd? And how many real zeros do you have? And that should cover it, so you should be able to do 12 through 22 even of the homework. So take a look at that tomorrow in class.